Good morning, all of you. In this particular lecture, we will be discussing some fundamental things and how they are linked with artificial intelligence and machine learning. In that, we will try to cover most of the concepts: reasoning, problem solving, knowledge representation, planning, learning, perception, motion, and manipulation. So, we will see those concepts one by one. So the first concept is reasoning. So from the word itself, we can understand that while making any kind of decision, we also make certain reasoning process. So what is that? It is the process of deriving logical conclusion and making some kind of prediction from available knowledge, facts, data sets, or belief. Or in simple words, we can say that reasoning is a way to infer facts from existing data. So the way we process the data, that process is very important. If we process the data by using incorrect method, then you will not get the correct solution. Okay. For example, if you design the gear by using only considering the beam strength, then your answer may be correct, but that would not be the best solution. But if you design the gear by using beam strength as well as wear strength theory, then you will get a better solution. So this is how you have to evolve, put logical reasons in order to carry out decision making. Again, there are basically 6 types of reasoning. First, we will see one by one with simple example. So the first type is deductive reasoning. It is deducing new information from logically related known information or fact. So basically here, the facts are used to make some kind of decisions. For example, if we assume all human beings are vegetarian and Suresh is a human, then from these two logical concepts, when we correlate with each other, we can easily say that Suresh is a vegetarian. So this is how we use our logic and our previous facts or information to make some decision. So this is how we deduce the information and make some decision. Second type is inductive reasoning. It is a form of reasoning to arrive at a conclusion using limited set of facts by the process of generalization. So in this case, what we are trying to do, based on our understanding level or previous experience or some sort of data, we try to make a thing in a very generalized way, and that's why we could able to differentiate between male and female. When some image is placed in front of you, then you can easily conclude then whether it is a male or a female or something else. For example, suppose you visited a zoo and there is a penguins. There are penguins, and all the penguins in the zoo are of white color, and you visited several zoos where you found out that the penguin's color is white, then based on this limited data set, what you can conclude, that all penguins would be of white color. So you studied a limited data set, and based on that limited data set, you try to make a generalized statement that all penguins are of white color. Okay, your conclusion may be wrong, but whatever limited data set that you have, you make the generalized statement, right? Then third one is adaptive reasoning. In this case, the logical reasoning is also there. We start with a single or multiple observation, then we seek to find the most likely explanation or conclusion from the observation. Okay, so for example, suppose you found that the cricket ground is wet, then what you may conclude, that there is a rain. Okay, so this is one kind of approach of reasoning. So basically what we seen in this, in case of deductive reasoning, we understood the facts, or we make some conclusion based on facts or some information. In case of inductive reasoning, we collect a sample data set, and from that sample data set we try to make a generalized statement. For example, based on our limited data set, we concluded that penguins are of white color. And in case of abductive reasoning, based on some observation, okay, we make conclusion. For example, if you found that cricket ground is wet, you may conclude there could be a rain. That could be one of the reason. The next type is common sense reasoning. So many times we apply our common sense based on our all past experience. And for having a common sense, your past experience is very important. Again, in which circumstances you get that past experience is also very important. For example, one person can be at one place at a time. So this is very common sense. The same person cannot be at two different places. If we try to make a statement that a same person is at two different places, then nobody will believe in you, and they will tell you apply your common sense. This is practically impossible scenario. Again, in another case, if I put my hand on a fire, it will burn. So this is very common sense. And generally in our day-to-day life, if some activity we have to do, then it is required to apply some common sense. And similar things we can expect from the artificial system, that whatever it will learn from the past data, it should learn, and accordingly the behavior should be met. Then the next type is monotonic reasoning. So in this case, once the conclusion is taken, then it will remain the same even if we add some other information to existing information in our knowledge base. For example, we know that Earth is revolving around the sun. So this is a universal truth, and that we know. And this is the observation made since long back. So thousands of years this observation is there. So it is a monotonic reasoning, and this is very common observation. And we should not get confused in between, or if we add something else that the moon is revolving around the earth, then also the earth is revolving around the sun. So that is the fact. So that such type of long-term universal truth are a kind of example of monotonic reasoning, and that is true for all the period of time. Then another reasoning is there, that is non-monotonic. So in non-monotonic reasoning, some conclusions may be invalidated if we add some more information to our knowledge base. Okay, this is also very important, because in case of monotonic, any additional information will not change the fact or will not change the conclusion. But in case of non-monotonic, the conclusion can be changed. Okay, so we will take two examples. First example is, we know that bird can fly. So this is very obvious reason. Then second observation, we know that penguins cannot fly. That also we know. Then a particular bird is PT. So we can conclude that PT can fly. Yes. And next time, suppose PT is a penguin, then your conclusion will change that PT cannot fly. So this is again non-monotonic reasoning. Again, we will take another example. So related to the space, right? So when the sunlight is coming to the earth, the how it is, the where is that sunlight is propagating or coming towards the earth. So what is there in the space? So one theory was saying that there is nothing in the space, and in the 15th or 14th century, long back, I don't remember exactly the year. So the Newton proposed that in the space there is a ether, and through that media the sunlight comes to the earth. And for many years that is considered as a true situation. But after few years, the theory was changed, and it is another scientist concluded that there is no ether and there is nothing in the space. So what I wanted to convey here is that in case of monotonic reasoning, whatever conclusion is there, that will not change over the period of time. However, in case of non-monotonic reasoning, there is a chance that the conclusion will change over the period of time. And again, the common sense needs to be developed based on the past experience. So whatever classification we have seen of reasoning, so all kind of outcomes we are expecting from the machine learning and AI techniques. Again, we will go ahead with the problem solving. So in case of problem solving, the first case is we need to understand that when the theory of artificial intelligence and machine learning started, so how it starts? So it started with a very simple things. For example, the early researchers started developing algorithms that imitate step by step reasoning that human use when they solve puzzles or some logical deductions. So the way with which we people do simple things, so similarly a robotic system or AI programs are designed and developed. For example, in this figure you can see this is one station and this is another station. Okay, and what is the role of this particular robot? It will come to the first station, either this or that, and it will pick the component to place on other station, right? So the movement is done step by step, how much distance it has to cover to collect the component, how much force it has to apply to lift that component, how much distance again it has to cover to go to the next station, and how it is to be released on the second station so that it will not get, the product will not get damaged. So these are the simple steps. In a similar way, if we replace that robotic system by machine, he will also think in the same way. So same step by step procedure is developed in terms of algorithm, and that robotic system is trained, and that's why we called it as a pick and place robot. Again, by late 1980s and 1990s, AI research had developed methods for dealing with uncertain or incomplete information. See, in first example, what we have seen, we know what exact procedure we have to carry out, and accordingly the algorithms are developed. However, over the period of time, even in case of limited information or uncertain situations, there is a need of taking some kind of decisions, and that's why the AI algorithms are developed that can work or that can make decisions even though information is incomplete, the situations are uncertain, and so on. For example, do not consider initially this particular part, only consider other part. So these are the blocks placed one over other, and what it has to do, there is a system, they have to pick the blocks and place in a such way that there is a sequence of A, B, C, D, right? So sorry, C is here and D is there. Okay, so this is what we are expecting in a simple system. Now again, this is another situation. Okay, so from one to another to third case. Okay, so in this case, what is expected, the blocks are organized in a different way. Okay, suppose as a game designer or a trainer, you consider only this particular situation and you train that system how to place the block so that a sequence of A, B, C, D will be maintained, and the model is ready with you. And suppose next time this is a particular type of arrangement, then the originally the algorithm was trained for a different situation and this is new situation. So when your system which is trained for different kind of situation, it will not take correct decision and you may not get this particular situation. So what we as an engineer expecting that the system should learn that if this is a situation, how it has to make decisions so that the sequence of ABCD should be maintained. Again, if next time the situation is different, then how it has to make decision in order to maintain the sequence of ABCD. Next time the situation could be another one, and there are few more types of situations. So the people started working on the algorithms who can make appropriate decision in case of uncertain environmental conditions or in presence of incomplete information. Okay, so this is the traditional thought process, step by step approach, and the AI application in uncertain information or incomplete information. But again, many a times we human beings also don't apply step by step reasoning and problem solving approach because it is very slow and not sufficient for complex system. For example, if you are riding a car on the road and suddenly another car came in front of you, then you will not think that first of all I have to deaccelerate, then I have to apply the brake, then I have to reduce the gearing ratio, change the gearing ratio, and so on. You will not think in step by step. In a very small fraction of time, you do all the calculations simultaneously, and accordingly you take decisions so that there will be less probability of accident, or the your ultimate goal is to avoid accidents. So over the period of time, human understood that the simple step-by-step process will not be a practical solution for all kinds of problems. For solving simple pick and place kind of application, yes, step-by-step operation is absolutely fine. But when we talk about autonomous car, in that case, this step-by-step reasoning will not help. And there, you need to consider several parameters that in this case of in the case of this autonomous car and avoiding the accident, so you need to consider at what speed you are going, what is the braking capacity of your car, with what rate you need to deaccelerate your car, with what speed that other car is coming in front of you. So there are so many parameters you need to consider, process that information, and that decision should be made in very short time. So such type of algorithms are expected to be developed, especially when we talk about complex systems such as autonomous car. Okay, so this is how the problem solving approach is evolved from simple step by step to consider incomplete information to consider a very complex situation. Then we will go ahead and we will now talk about knowledge representation. So knowledge representation is very important because many a times when we write answers in the answer book, then we get marks based on how we present our answer. Few students, what they do, they write so many pages of answer for the same question. Few students, what they do, they write only very important and relevant things, and they don't write irrelevant information, so it will be a concise answer. Few students, what they do, instead of writing paragraphs, they present the same knowledge in a tabular form or a graphical form or a pictorial form. So this kind of representation is also important in order to communicate effectively. So knowledge representation in AI describes the representation of knowledge. Basically, it is a study on how the beliefs, intentions, and judgments of an intelligent agent can be expressed. This expression is very important, suitable for automated reasoning. For example, if somebody told you to find out the reasons of pen is not writing or fail is failed, then you can write the same answer in a different way. So somebody can present in this way. So when it is a pictorial form, we think that it is interesting. So we will consider the top event as pen is not writing, and the reason could be external or it could be internal reason. So if external reason is there, pen will fail. If internal reason is there, pen will fail. So that's why it is connected by OR gate. Then again, in external reason, there could be many reasons. So I have considered only two reasons, A and B. So due to some external force, the cover of the pen is broken down, or you tighten the threads or applied unnecessary force on the thread so that it has failed. So because of reason A or B, the external failure, due to external reason, the pen will fail. So occurrence of A or B will be leading to the occurrence of the event, that is pen is not writing. Similarly, internal reasons could be refill failure, that due to some internal reason that over the period of time when you go on writing, the ink will be empty. So that could be a reason. Or pointer failure due to human mistakes. So while writing, unknowingly you apply some extra force on the tip, and due to that it could fail. So that could be another reason of failure of the pen. So these are the some of the reasons because of which the pen you cannot write by using that pen. And if we write paragraph and paragraph, or if you think of putting in this very logical way, then the communication skill will be different. That is, the way you express that decides a lot. So knowledge representation focuses on how effectively the knowledge can be presented so that the other body or the community will understand in a better way. So that is another skill. So we need to train the AI programs or AI programs or systems so that it can present the knowledge, whatever it learned, in such a way that it will be a good expression of the knowledge. Again, there are different types of knowledge representation. So first one is declarative knowledge. It includes the concept, facts, objects, and expressed in a declarative sentence. For example, COVID protocols. So the social distancing, sanitization. So all these are declared to you and you have to follow these as a guidelines. So these are the declarations made by the government and you need to follow it. Second is structural knowledge. It is a basic problem solving knowledge that describes the relationship between concepts and objects. So when you compare the structural knowledge with declaration, there is a huge difference. In declaration, certain guidelines are given to you and you need to just follow it. Whereas in structural knowledge, you will try to act accordingly based on certain relationship. For example, we know that the relationship of temperature and performance of human. So we know that if temperature is very high, your efficiency goes down, right? So that's why in summer, if there is a air conditioning system is active in the classroom, your focus will be greater. Or if there is no proper ventilation and no AC or no fan, and 70, 80 students will be in the class, then it will be very difficult for you to concentrate in the class. So based on some known relationship. How we are presenting that knowledge is also very important. That you need. Okay, so
Hello,
attend.
sir.
Yes, I guess I lost internet connection and I don't know when I lost it and how long you. Uh, it was on mute, I would say. Okay, but
Yes, sir. Audible now.
yeah, audible. So when I lost my internet connection, can somebody tell?
Instructional knowledge.
Oh, so after that I spoke a lot. Did I cover types of learning? Did I cover types of learning?
No, sir, you covered types of reasoning, knowledge representation, and structural knowledge and derivative instruction.
Okay, so planning I missed, learning, types of learning, natural language perception. Okay, so that's fine. So what we will do tomorrow in upcoming class, we will cover the same. Okay. So I didn't, I did not came to know that when I lost the internet connection, but that's fine. In next lecture.
11:30, near about 11:30.
Oh, so half hour. Okay.
Yes, sir.
Okay, that's
No
fine.
problem.
Okay, that's fine. In next lecture, we will cover the same. Okay. So use the attendance link which is given in the chat box and you can leave the meeting. Okay.